Okay. There we go. Welcome back to another. Okay. Oh, there we go. Audio on YouTube. Sorry about that. Yeah, there we go. Advent of Code. Day 8, of course. Again, same procedure as always. I haven't looked at this. Going in blind. I have been I am in the NIM AoC channel. I've been trying not to read anything, and it's getting harder because people on the forum also keeps asking questions about like trying to use NIM for this stuff, and I want to help, but I can't spoil the challenge for myself. So yeah, anyways. Let's look at day 8. Ooh, spicy. Okay. 7 segment search. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Oh right, yeah, we're heading into a cave. So I guess this is the cave then. And we sort of got in through there. Oh, sorry. What a sneeze. Ay. Okay. Yeah. So we barely got in before the whale smashes into the cave mouth. Cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth. So you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment display, so these are just the normal, like these things, the normal sort of can write in 8, and with that you can write different characters. In your submarine are malfunctioning. Uh-oh. It must have been damaged during the escape. Oh. Yes, just the 4-digit 7-segment ones. Whole batch must have been faulty. Right. Must have been damaged during the escape. You'll be in a lot of trouble without them, so you'd better figure out what's wrong. What are they for? Doesn't say. Each digit of a 7-segment display is rendered by turning on or off 7 segments named A through G. So I'm guessing these are the same ones that were displayed here. So A, B, C, D, E, F, and G. Right, and here we have, yeah, A, B. Oh, this is actually not the same order. A, B, C, D, E, F, G. Okay. And these are all the digits. So to render a 1, only segments C and F would be turned on. The rest would be off. To render a 7, only segments C and F, of course, because those are the same as in the 1. And the top one, which is A, would be turned on. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on signal wires A through G, but those wires are connected to segments randomly. Well, that's not great. Worse, the wires/segment connections are mixed up separately for each 4-digit display. All of the digits within a display use the same connections, though. Right. Okay. Yeah, so a 1 might now be like a BF, but it's for that display, it's always going to be a BF. It's not going to be different. So you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1, so it must mean segments C and F are meant to be on. With just that information, you still can't tell which wire B/G goes to which segment C or F. For that, you'll need to collect more information. For each display, you watch the changing signals for a while. Make a note of all 10 unique signal patterns you see. And then write down a single 4-digit output value, which is my puzzle input. Okay. We make a note of all 10 unique signal patterns. So these. Right. Using the signal patterns, you should be able to work out which pattern corresponds to which digit. For example, here is what you might see in a single entry in your notes. So A, B, C, D, A, C, E, D, G, F, B. So this would be, wait, yeah, that's all 7 turned on, which is none of them. Oh, wait, yeah, 8, of course. Yeah, so this must be an 8. This, of course, is a 1. This is a 7. So on and so forth. The entry is wrapped here to 2 lines, so it fits. In your notes, it will all be on a single line. Yeah, so this is just to break it up. Each entry consists of 10 unique signal patterns, a pipe delimiter, and finally the 4... Oh, right. Okay, so this is actually in our input. A pipe delimiter, and finally the 4-digit output value. Within an entry... 4-digit output. So these should be 4 digits for... Wait, what? Within an entry. Within an entry, the same wire segment connections are used, but you don't know what the connections actually are. Within the same wire segments, okay. The unique signal patterns correspond to the 10 different ways the submarine tries to render a digit using the current wire segment connections. Because 7 is the only digit that uses 3 segments, DAB in the above example means that to render a 7, signal lines D, A, and B are on. Because 4 is the only digit that uses 4 segments, EAFB means that to render 4 signal, lines EAFB are on. Using this information, you should be able to work out which combination of signal wires corresponds to each of the 10 digits. Then, you can decode the 4-digit output value. Unfortunately, in the above example, all of the digits in the output value use 5 segments and are more difficult to deduce. Right? For now, focus on the easy digits. Consider this larger example. These are more lines. And they have highlighted the easy ones. Because the digits 1, 4, 7, and 8 each use a unique number of segments, you should be able to tell which combinations of signals correspond to those digits, counting only digits in the output values, the part after the pipe. In the above example, there are 26 instances of digits that use a unique number of segments, highlighted above. So these ones. In the output values, how many times do digits 1, 4, 7, or 8 appear? Oh, that is the question. Okay. That should be easy. So here is our input, of course, much larger than the then the test set. So we'll store this as input.txt. And then let me grab this input as well. Store this as input example. Getting a phone call. Decline that. Crap. It wrapped stuff. There we go. There. Right. I just have to answer in a text real quick. That I'll call them back later. Let's see. Right. So, we have our input, our example input right here. So we see we can split this on the pipes. I just want to verify, yeah, that they're formatted the same. So we can split on the pipes and have sort of all and the output. Let's see, probably need string utils. And then this is actually something I saw someone do, which is pretty neat. Instead of sort of parsing stuff into a sequence and then iterating over the sequence, they wrote their own custom iterator. So I thought we might try that today. So write an iterator and call it, well, we only want to parse the outputs. So let's just call this iterator outputs. And then have this, which is the name of the file. And this yields strings, I guess. Or actually it yields it can either yield a tuple of 4 strings or just a sequence of strings. I'm actually going to go with the tuple A, B, C, and D, and these are all strings. And now we can do inside our iterator for line and input for line and file.lines. So this is the same iterator that we have been using. Line split on this thing. And we want the second part of that. And we want to split this on space, I guess. That's actually just character. That should give us a sequence. And then we can yield, let's outputs. Ooh. Let's just call it O, since this iterator is called outputs. Yield. And now we just create a tuple. This is a bit clumsy, but whatever. It would have been easier to just return just return this and have a sequence. You know what? Let's just do that. It's easier. Just yield that, and then do a sequence of string. So this basically means that we now don't have to we don't have to store these in a long sequence just to iterate over them. We can sort of iterate over them and free them, free the stuff that we don't need anymore right away. Which, I mean, for this doesn't matter, but it's a pretty neat little trick. And we want to do import example.txt. So now if we do this, we should get all of our small, all of the sort of second parts. And that looks to have worked fine. Right, and now we want to count the 1s, the 4s, the 7, and the 8s. So we want a count out here. And then we want to do, I should do a case on output. Oh, we have 4 outputs. So for digit in the output, case over the length of the digit, and then we need the different lengths. So one is 2 segments, 7 is 3 segments, 4 is 4 segments, and 8 is all 7 segments. So that is 2, 3, 4, and 7. 2, 3, 4, and 7. Increment the count. Otherwise, just continue the loop. Now we can echo out the count. And this should yield 26, which is the answer for the test set. So now if we change this to our actual set, there we go. We should now get another number, which was 470, which should be, hooray, our correct answer. So now we are 1 gold star closer to finding the sleigh keys. I'm guessing the second part is going to be significantly harder. Let's start by just copying part 1 over to part 2. Part 2. There we go. So now we have that ready. Through a little deduction, you should now be able to determine the remaining digits. Consider again the first example above. After some careful analysis, the mapping between signal wires and segments only makes sense in the following configuration. So this is the configuration that he comes to. So AB, for example, we know this has to be a 1. You can see this is a 1. This 3 we now have to be a 7. So if this is a 1, if AB is a 1, then D is obviously the top line. We know that this is a 4. So this is a 4, EAFB. But we don't know where E and F are. A 6, for example, would use D, E and F, and B, and then G and C. So now we know, well, like working backwards, we could have figured out that these two, like these 3, since we haven't, actually these 2, since we haven't seen them before, we know that those have to be down there. And then, so for example, a 5 is this shape, which uses this, but not this. So then we can figure out what this one is, and so on and so forth. So the unique signal patterns would correspond to the following digits. And these are just, yeah, as I said, AB is 1, DAB is 7, EAFB is 4, so on. oh yeah, when we know the middle one, like we know the one that uses all the segments is an 8. As soon as we figure out the 4, actually it has 2 unique ones. So when we figure out the middle one, we know the 0 one. Actually, we can know that straight away because it's the 1 that is missing between an 8 and a 0. It's the middle one. And then with a 4, we can figure out this one because we already know these 2, so on. Then the 4th digits of the output value can be decoded, 5353. Therefore, the output value for this entry is 5353. Following the same process for each entry in the second larger example above, the output values of each entry can be determined. So these are those. Adding all the output values in this larger example produces 61229. For each entry, determine all of the wire segment connections and decode the 4-digit output values. What do you get if you add up all the output values? So, simple enough. Let's do this and have segments is a sequence of string and output is a sequence of string. So now we're expanding this this definition here to be a tuple. We can actually do this. So now this one is applied to both of them because this one doesn't have a type. If we did this, it would mean that this didn't have a type, so that would be an error. So here we can now say we want to yield line.split. Oh, actually, let's do this. Oops. There. And then we yield pair 0.split on this thing and pair 1 split on that thing, and that is the tuple. So if we now do this, this should be the same as before, but now we also have output.segment, which will give us the 10 first ones. So now we need to do a little detective work. Right. So we know we need to map these. So we obviously need to have a list of what, like, the correct mapping to digit. Actually, do we need to keep that? Maybe we don't. So we can know. Now I'm just sort of thinking out loud. So digits, if we map this as, I should do this for every input. Digits is going to be an array from 0 to 9 of a sequence of, actually of a string. So these are the mappings. And then we know if it's a 2, then we can say digits 1 is equal to digit. And we can do the same for 3. Digits digits 7 is equal to digit. If it's a 4, we can do digits that would actually be a 4 is equal to digit. And we can say if it's 7, then digits 8 is a digit, or is the digit. So now we have the first ones. These can just be read out directly. So now we should have, if we run it on this input, so if we do, that actually reads from a file. It's a bit clumsy. Let's just, for now, ignore that file. Yeah, let's ignore that file and do, pop this in a block so I don't have to dedent it. And let line be this thing. We're just testing stuff out now. So there, if we now echo out the digits for this test input, and actually we want to do this both, actually do this for the segments. Oh wait, output dot segment. There. If I now run this, oops. Oh, wait, no, that should work. Oh, build the part 2 version. And this now output, so we know that 1 is this one, 7 is this one, 8 is this one, and this one is 4. So I said we could know the 0 immediately, but we can't because it's the same length as a 6 and a 9. So we need to do a little bit more detective work to be able to tell stuff like that apart. So let's scroll up to this thing. So now we know 1, we know 4, we know 7, and we know 8. That means that if we overlap, we know that B and D are these two. And in this example, B and D have to be this place and this place. We know that the top one has to be the one that's in 7 that is not in 1. But that, yeah, so we can have that from knowing that. We know these from knowing the 1. So this is the same length as this, of course. So that doesn't actually give us anything because we don't know. Oh yeah, we know this one. So we can find the 1. We can figure out the difference between a 2, 3, and a 5. Should be fairly easily. These are all the same length. So 2, 3, and a 5 are the same amount of segments. Oh. Someone is talking to me on IRC. Right. So let's have a look at the 2, 3. So we should keep. It's really annoying that these aren't sort of sorted by length. There's no reason why they aren't. Is there? No. So we can't just sort them by length. That would make our life a little easier. Sorted. Wait, can I pass sorted a function? That is sorted, which is not what I wanted. Sorted here. Right, yeah, okay. So I can pass it an open array, I can pass it a procedure. So I can say can say I want just a length procedure. Does that work? No. System.length for a string. I was just going off of what with this. Oh, right, it's a comparator. Damn it. Okay, so we have to do an inline function here. Procedure that takes x and y string, returns, I guess, an integer. Yeah, integer should just be x dot length minus y dot length. That should sort it somehow. What is this complaining about now? Oh, right. Sorted is in, wait, in algorithms? Algorithm, yeah. Sorted is in the algorithm module. So we can now do this, and we can now, echo out the, echo out the output.segment. This should now be a sorted list. Oops. Echo. This should now be sorted. And it is. Great. So of course, the ones that have the same length are gonna just appear after one another. But that should be fine. That means we don't need to actually loop over these. We can now just say that digit 1 is equal to output segment number 0 because it's the shortest one. This is going to be output segment 1 because that has 3 characters in it. And then 4 characters for the 4. So output segment number 2. And this should be output segment number 9. Because there are 10 entries. And then we can just move this. And this. Oops. There we go. So this should now give us this same list. And it appears to be correct, which is great. Why is this 7, 8? Oh, 9, of course. Right. So now let's figure out some stuff. So we have 5, 6, and 2, 3, and 5, which should be able to tell the difference between these, knowing just what we know now. Because of these, only the 3 has both these set. So the 3 is the only one that contains both the ones that are in 1. So we can figure out, so look at all the ones with 3s in them. So that is the ones that index 0, 1, 2, 3, 4, and 5. Oops. So at position 3, 4, and 5, we have to look at these. And then if output segment I contains digits 1, I think contains can do a whole string. Guess it's time to find out. But it doesn't have to be in order. So let's do this and output segment I dot contains digits 1, 1. Then we can break out of the loop, and we know that this is digit number 3. There. Oop. Contains what? Char bool. Oh, this is just precedent issues. So it was doing the and. It was doing the and on this and this instead of on this and this. That's what that error was. So we run this. We can now see that we have the 3 in here, which contains both A and B, which makes sense because that's this one. Oops. It's probably a better way of doing this, but this is fun. So now we know. So both 5 and 2 is going to contain, is going to have one difference. But telling them apart, we can go by the one that contains something that's in the 4, because the 2 doesn't have this from the 4. And since we know these, we can know this one. Because these are the ones in the 1, and wait, do we know this one? I guess we don't know this one actually. So we still haven't figured out the 9. Right. So I guess we should try and figure out what this one is. So we know these because we have the ones from the 1 and the 7. But the 4 and the 3 both share this one with the 8. If we diff these characters, we have this and this and this. And we know this from the 7s. We have this and this. We can get these 2 from diffing the 3 from the 8. But that doesn't really, well. So the 9 is missing 1, and the 6 is missing 1, and the 0 is missing 1. So these 3 are all 6 characters long. And if we take the 8, so that's all the characters, and we subtract the 3, we're stuck with B and E. And 9 is the only one that should miss a B or an E. Right? Because 0 has a B and an E in it, and 6 has a B and an E in it. Similarly, we can also figure out the 6 because that's going to have to miss the C and the F, or C or an F, because both 9 and 0 has a C and an F in them. Right, so that's one way of doing it. So let's figure out the 6 first. So we take the 8, we take the 8 and we take all of these, and we see which one is missing either C or an F. Right, so for I in, and that would be 0, 1, 2, 3, 4, 5, so 6, 7, and 8. Uh, 6, 7, and 8. I guess we really should convert these into sets. That would make this a lot easier. So let's convert these into a set. I want to map this. Let's see, we have the so we do have the sets module, which is a hash set. And this can be created directly from something. Let's see. Yeah, to hash set can take an open array of something. But we don't really want to use a hash set. Nym also has a built-in set type, which is this thing, which is bit sets, which is all that we need because we only have 7 characters. But for this, I think we actually need to include all the characters manually. So let's do map it. And we're going to put in here, let's do this a bit nicer. Something like that, sure. Then we can do, we now get strings. So the output of this should be a set of characters, and for C in it, outputs dot include that character, and then return the output. And now this should return a, this should return a set of characters. And this should also be a set of characters. Let's uncomment that for now. This didn't seem happy. Let's see. Map it is, of course, from secutils. But that is still not happy. Try to wrap this in a block. That got me closer. Named expression. I guess it's just not happy with doing all of this in a single line. Can I do this actually? Didn't seem super happy, but now it should actually be more correct. Let's see. Type mismatch. Got a sequence of a set of characters. That's not what we want. Oh yeah, of course, that is what we want. I just typed this incorrectly. There we go. And now, of course, down here, we can do the one, wait, so this checks that it contains both of these, which is the same as saying the output segment I minus the digits 1 set has a cardinality, so a size. So since it needs to contain both of them, if I subtract both of them, so we know that each of them are the same length. They're all 5 characters long. When I subtract A and B from one of these, the only one that goes down in size by 2, which will be this one, is now going to be a size 3. The other are going to be different sizes. So you can check that this has a cardinality that is 3. And that should give us the same output as before. Of course, now expressed as sets. So we have AB for 1, nothing for 2 yet. We have this for 3, which is correct. And 4, 5, 6, and then 7 and 8. So A, B, C, D, F should be the one that we had up here. A, B, C, D, F. Yes. Great. This just makes our comparisons a little bit easier. I wonder. We can tidy that up afterwards. This works. So where were we? 6 and 8. So now we're looking at. The ones that are 6 and 8. So that is the 9, the 6, and the 0. And we're trying to figure out the one that decreases only 1 in size when I remove this set from it, because that will be the 6. So if the output segment minus the 1 digit has a cardinality of, and these are all, of course, 6 characters long because they miss 1. So if it goes down to 5, then we know that this is the digits 6. Okay. And now that we have the digit 6, well, we can see. So yeah, if I subtract a 4, for example, which we also know. So if I subtract a 4 from this one, and this one, actually not a 4, that would be a bad choice. I was basically trying to just check for this one. For the middle one. So, but we don't know the middle one yet. Can I check for this one somehow? I don't have any characters that I know contains this one. So that is not a check I can do. I mean, I do have the 6, but that is after this loop. I'm trying to figure out if I can do something within this same loop and do 2 characters at once. This one is missing that center one, while this one is missing this one, and this one is missing this one. So I would need a character that doesn't have, well, that would differentiate those. So yeah, so if I subtract the 4 from this, that is going to remove 1, 2, 3 lines from a 0. It's going to remove 4 lines from a 9, and it's going to remove 3 lines from a 6. So I know if I subtract a 4 and it becomes 4 shorter, then I know it's the 9. So if the output segment I minus the 4 digit has a cardinality, and remember these are cardinality 6 originally, so if it goes down to 2, then that means that this is a 9. Can we do the 0 as well in a single pass? It would be super easy to figure it out now because we know like it's the one that is not one of these. Actually, we could do this. Because we only have 3 digits, and it has to match this one, or it's the 0. So now we know, now we have the 0. Which are we actually missing now? We have the 1, we're missing the 2, we have the 3, the 4, we're missing the 5, and we have the 6, the 7, the 8, and the 9. So we're missing the 2 and the 5. So differences between a 2 and a 5, they are both the same cardinality. Subtracting a 1 from both would yield the same thing. Subtracting a 9 from both. So subtracting a 9 from a 0 would yield a cardinality of 0. But subtracting it from a 2 would yield a 1. So now I can figure out the 5 and the 2. Thanks, Juan Carlo, for hosting me. And I have got some more questions. I totally forgot to answer questions. Oh, and hello, Frederick. Welcome. Yeah, what VM do I use? I use i3, or I use i3 on this machine, but then I use Nimdo, which is a tiling window manager written in Nim by Prestige or Avahe. I'm not sure how he pronounces his first name. Kellenberger, I guess. Yeah, so I use this at work, just because I haven't been bothered to install it on all my machines yet. It's pretty good. Copy. I solved part 2 with fusion/matching. I'm questioning myself why I haven't tried it earlier. The code is so clean. Ooh. Do you have a link to your repo? It'd be cool to have a look at it afterwards, after I'm done. Right, so now we have, what are the length of these? There would be 1, 2, 3, 4, so that should be 0, 1, 0, 1, 2, 3, 4, wait, what? Right, that's the same length as the 3 that we use here. So the 2 and the 5 are the same length as the 3. So it's the same as this loop. Do we actually use the 3 down here? We don't. So we can move this loop down and do it after this one, because we don't actually use digit 3 in any of the checking here. So the order there doesn't matter, because now we can figure out, we can do this, output.segment I minus the digits, the number 9 digit. If the cardinality of that is now equal to 0, that meant that it was a 5. Output.segment I. And otherwise, we know that this is now a 2. There. So now we should have all our digits. And it appears that we do. Great. Now we have all our digits. Now it's just a matter of decoding our inputs. We still have our input as a sequence of strings, that should obviously be changed. We're gonna do this and just pop that on there. Remove that. That is the correct number of those. I'm gonna take this. I'm gonna split that out. So we're gonna write a to set that takes a string and returns a set of characters. We're gonna do this. Move all of this to there. Output, of course, we don't need that because in nym we can use result. Result is the implicit return value. So it will always have the same type as your return type. So you can build your result up directly in the result type. And this can trigger a compiler optimization that actually copies the memory to that position on the stack instead of creating an object and then returning it. So copying it from your stack frame to the caller's stack frame, we can build the result directly on the caller's stack. This makes sense if you know how C calls functions. If not, then maybe it doesn't make sense. Someone has shared a picture of my screen. Oh. Wait, oh, this is from a year ago. Wait, what? What? Somehow the stream for today, which can't have comments yet, has shown up with a bunch of weird comments. Yeah, your YouTube is lagging out, it seems. Right. And I see Hamid Reza Buluri says that tonight was a nightmare for me. That is sad to hear. But yeah, now we can do this, and we can say just map to set on there on this, and we can map to set on that. And let's actually split this up there so it looks a bit nicer. The jury is still a bit out on like formatting in them. There we go. That doesn't look half bad. So now our outputs, like these parts, are also sets, which is nice. Now we have all our digits, and now we need to match them to our newly found digits. So for element in output.output, I should have named these something better. And then what is the best way of converting this to converting a sequence of these sets of characters to the indexes of their positions? I guess we can do something like this. And instead of looping over that, we can loop over I in 0.9. And then if digits I, I should do this double loop. So if the digit in output.output if this is equal to digit, then number is equal to number times 10 plus I. So times 10, that just makes the existing number 10 times bigger, so it moves it one space over to the left. For you guys. And then add on the index. So that should work. Echo out the num. Just move that there. That should work. 5353, which is, if you go back here, 5353, which is the example that we're working with right now. So that seems to work. So now if we apply it to all of the ones in our test set, so if we remove that and go back to this, and also clean this up a bit by making this a single let statement instead of two separate lets. Now it should do this for all of the lines in the input. I'm actually gonna echo out the outputs. They're ordered. You can figure it out. Oops, let's not echo out all the segments, because that's a bit noisy. Ooh, it's always 5353. That is obviously not correct. Oh, don't do that part. There we go. That should be correct. And if we do this for our example input, we can see 8394, 8394, 9781, 9781, 1191, it's 1191. So all these looks like they're correct. And if we now do count plus equals the number that we found on this run, we should, and oops, we also of course need to echo out this count. 61229. 61229, that is correct. So if we now just run this on our input set, our actual input set, this should be the correct number. Hooray! There we go. We're one gold star closer to finding the sleigh keys. So now we can see we're entering into the cave. You see the colors. The colors are starting to appear as we go into the cave. I'm guessing this is the exit from the cave. So we're probably going to be in the cave for the next one, and then heading out of the cave on the day after that. Right. So that was, it was a bit trickier than the previous ones, mostly because we had to find the logic for deducing the numbers ourselves. In the previous ones, we have more or less been just given, like, here is the logic, just implement it. But in this one, we actually had to figure out some of the logic ourselves. So this was a bit trickier. It's probably a lot of easier ways of doing this. This is a bit wonky, but it does work. Yeah. I mean, it's not the worst code in the world. And we got to show off some nice iterators. Instead of copying all our inputs into a large, so this could of course have been put into a sequence, and then we could have looped over the sequence. But then if our input was super big, then we couldn't hold our entire input in memory at the same time. But this just loops through, and we can discard the tuples as we're done with them. We also got to see this nice this nice result thing. Of course, you could argue that this should probably be somewhere in the standard library, and it might be actually. I didn't really go looking for it. It's not something that I use terribly often. Yeah. So this is pretty neat. Again, you can find the repository where I post all my code on my GitHub. So PMunch/AoC 2021. Here you can see all my code. Also a link to the YouTube channel that has a playlist of all the days. I see that I forgot to add 6 and 7 to the playlist, so I will do that afterwards. And of course, 8. You can also, if you want to get notified when I start streaming, you can subscribe to Twitch, or you can subscribe to my YouTube channel. Not sure if you get notifications then. To be honest, I'm not sure if you get notifications on Twitch either. But yeah, if I keep streaming through December and I get 3 more followers on Twitch, I become a Twitch affiliate. I don't know what that means, but they keep sending me emails about it. So if you want them to stop spamming me with emails, subscribe to my Twitch. The worst interaction pitch ever. So someone shared their code here in the Twitch channel. Let's have a look at that real quick. Okay, they have the test input and split lines and map. Okay, yeah, so similar to what we're doing. This would return a tuple of these array sequences of strings, same as we did before. Test output to test against. That's pretty clever. Use a hash set. So hash sets, they are going to be slower than the sets that I'm using here, but they generally have more functions. You can do more of them. Like you can put anything in a hash set, but for putting characters in, they're a bit overkill. So you should always, like when you're designing stuff, you should always try to go with like the smallest thing that works. If you're putting up a picture, you should get out a normal hammer and not like a nail gun to put the nail in to hang a picture on, and a compressor and everything. Yeah, so for patterns, split white space, and then filter by length. Yeah, so you get out all the lengths, and then you've put those in a unique, which is a table. Okay, interesting. Turns the pattern into a hash set. This is the automatic thing that we were missing, which meant we had to implement our own function. Let me actually increase the size here a bit. So yeah, by the way, this is the Nim playground. So you can run the code directly on the playground. And as long as this doesn't take more than, I guess it might have actually timed out. It has a runtime limit and can't use the network and a bunch of stuff like that. So it's quite limited, but it works for sharing like code snippets and bugs and stuff like that. And to play around with. I actually use it quite a bit. Yeah, so go through the digits. What on earth are you doing here? You're doing a case. What? You're casing over an array of tuples, turning that into a table, and grabbing out keys from the what? How do you do that? Oh, you have case statement macros. And I guess that might come from fusion matching, or yeah, from fusion matching, I guess. So yeah, you case over a table, and then you get out all the lengths. And you add the results. How on earth does this work? Common with 1, you add a 3. Common with 1 and common with 4. I have no idea how this works. But that's what's cool with these. You get different solutions, and everyone will find their own different solutions. I mean, some of them are pretty obvious, but yeah. I think I'm gonna call it the day here. I have other stuff to do. Hope you enjoyed the stream. As I said, you can subscribe if you want to see more of these streams, or you can go to YouTube and see all the recordings. Oh, I have some more comments on YouTube. Thank you for so much. You do more NIM embedded, please. Yes, NIM embedded is probably gonna come up more. I am now doing some home automation stuff. So I can like turn off the lights and I measure temperature and stuff like that. I want to automate some stuff, and I also want to write more code for microcontrollers. So right now I have stuff like this, which is just an Arduino or a free Arduino board with a small like radio control chip. So I want to have that running in them. In general, I've been thinking that Badger, my keyboard firmware, is a pretty cool project, and I want to do more with it. And I want to set up a framework that can do compile time abstractions for microcontrollers in a more sort of coordinated way. Now we can run them on a lot of different microcontrollers, but there's no sort of combined effort to make code run between them. And that's sort of what I want to do. I want to be able to take my keyboard firmware, and then someone can download it and just specify which chip they want to run it on, and bada bing, bada boom, you're up and running. That would make it a lot easier. Like if I write a library for a sensor, you can use the library for the sensor, even though you're not using the same chip as I am. And this is something that I believe is going to be very important if we want to get NIM running on more embedded devices. So that is sort of my next super big project. I also have another project where I'm building a e-ink laptop, which I have written a compositor thing in NIM that turns NIM that turns my screen to signals to the e-ink screen, and that works really well. Now I just need to pack it all into a laptop. I have an old laptop that I'm going to be using. I've got this cool Kadas controller board for it, which is going to be cool. But that needs some firmware for the keyboard. So I'm actually going to be porting my keyboard firmware to run either directly on the Kadas or on a microcontroller that I put inside the laptop. So yeah, I am gonna be doing more embedded stuff, and hopefully stream it, or at least keep talks about them. But yeah, that's it for today. I think I'm gonna have time to do tomorrow's stream as well. Somewhere around here, I am leaving Tromsø, so I'm not sure about the rest of the month, but I'm gonna keep streaming until I can. So that's all for today. I hope you enjoyed the stream and hope you're enjoying Advent of Code. Well, I hope you're enjoying Advent in general, not just Advent of Code. So have a nice Advent and Merry Christmas when that comes around, or Happy Hanukkah, or I guess those are the ones that are this time of year. Happy holidays, whatever kind of holiday you celebrate, or even if you don't celebrate holidays, just be happy. Just even if you don't get to celebrate anything, just be happy. Okay, that's it for me.